Okie dokie, here we go. Alright, here's actually the first question that counts on the test, and we won't do all of them, and I'll just kind of hit some of them. I'm kind of looking at what you'd be expected to do on an AP test for this. So read this question. Marathoner runs 26.2 miles in 2.7 hours. Did the runner ever exceed 9 miles per hour? What you're basically looking at is you need to recognize that you're talking miles per hour. You can calculate an average speed here, and we want to know if the runner actually exceeded a actual speed of 9 miles per hour. And you have to see that you can calculate. You have to see that there's a relationship, or you have to understand what's a relationship between average speed or average rate of change and instantaneous speed or instantaneous rate of change. And how are they related? And basically they're related like this, and we've drawn this picture in class quite a few times. I'll try to maybe draw it a little bit differently. If I've got 2 points in time and this graph is going down like this, the average rate at which it changes over these 2 points is the slope of this secant line. That's the average rate of change. The instantaneous rate of change at any point is the slope of the tangent line. And so what the mean value theorem says is, hey, there has to be some point in time where the instantaneous rate of change is equal to the average rate of change. And you can kind of see, well, you definitely can see it on this graph, but intuitively you can see it for speed. If somewhere in this marathon the average rate of the average speed, I should say, and we need to specifically say the average speed of this runner is 26.2 miles divided by 2.7 hours, which is 9.7 miles per hour. His average speed is 9.7. Well, if his average speed is 9.7, then certainly at some point in the race he had to have run 9.7 miles per hour, and therefore he ran over 9 miles per hour. We know that that's kind of common sense, but mathematically we have to justify it like this. By the mean value theorem, we have to state it by name if we're going to use it. By the mean value theorem, there is a point during the race at which the runner ran 9.7 miles per hour. Okay, and yes, of course there was a point he ran over 9, but the theorem doesn't say that specifically. The theorem specifically says there's some point during it that it ran, just like it says there's a point at which the slope is equal to the slope of the secant. So there's a point at which he ran ran during the race 9.7 miles per hour, hence exceeding 9 miles per hour. Okay, and formula wise, basically we said this to line up with the formula that many of you guys wrote. There, you don't have to write this for this problem, just for completeness. There is a C, so that f prime of C, that's the instantaneous rate of change, equals f of B minus f of A over B minus A. Okay, that's really all you needed, is right up to here on this problem. Alright, there you go. Okay, I wanted to hit this number 3 on the same video. Find the point of inflection for this. Remember, a point of inflection is where it changes concavity from concave up to concave down, or vice versa. It's not only where the second derivative is 0, but it's where it changes concavity, so I have to check that. So I've got to find out where the second derivative is 0. So changes concavity, so that means the second derivative equals 0, and y double prime changes sign. So you got to check both of those. So y prime is 3x squared plus 6x minus 1. Y double prime is 6x plus 6. Set that equal to 0, so I get x equals -1. Now I need to verify at -1 what happens to the second derivative. Please don't just write pluses and minuses here like this and this or whatever, because to a reader they don't know what that means and they don't know what you're doing. And for some of you, you might be plugging into the derivative, the first derivative of the function. It's not clear. So please do say double prime. So -1, so pick a number to the left like -2. If I plug in -2, then 6 times -2 plus 6 is in fact negative. So it's concave down. A number bigger than -1 like 0. 6 times 0 plus 6 is positive. So it's concave up. Then make this statement. Since y double prime changes from, actually here you can just say it changes sign, because that's all an inflection point does, is it changes sign. Since y double prime changes sign, I have to write sine, S-I-N-E, sign at x equal -1, x equal -1, y equal, and then you're going to have to plug in -1 into the original function to figure out what that is, and it ends up being -21. You can do it over here on the side. Y of -1 equals -1 cubed plus 3 times -1 squared minus -1 minus 24 is a point of inflection. Okay, doke. That's got it. Thanks.